Okay, so here are my answers to the matching and multiple choice part of the practice test, which was chapter test B. And the matching, there's no mystery there. You just have to, I don't know what to tell you. If you don't know these, you don't know them. Okay, usually you can just kind of get hints from the question about what the answer is. So there are the B, E, D, A, F, C. You can ask me about those when we come back if you need to, or email. Multiple choice on the first one. In a chemical reaction, both mass and atoms are conserved. That was on the the packet we did the other day. That were, the one that was on Tuesday, I believe we did that. So both mass and atoms are conserved. Number 8, which of these is correct interpretation? I don't like the fact that they called these, where are we at here? I don't like that they called these molecules, but other than that, they've got the right idea. The number of atoms to molecules is what the coefficients in the balanced equation tell us. Also tells us moles. So A and C are the right answers, so D is the best answer. Number 9, 3 moles of HCl are consumed in the reaction. How many moles of FeCl3 are produced? So 6 HCl in the equation, 3 moles out over 6, that's half, right? So if 6 is 3 and it's a 2-to-1 ratio, I'm sorry, a 6 to 2 ratio. So if 6 is 3, then 2 would be 1 mole. And there's the math if you prefer that. Oops. There, 1 mole. Next page, given the equation, how many moles of H2O would be required to produce 2.5 moles of O2? Just got to look at the coefficients. It's a 2-to-1 ratio between H2O and O2. So if we had 2.5 moles of O2, we're going to need 5 moles of H2O. And here's the stoichiometry of it, if you would prefer. Number 11, but on these multiple choice, right, you're not showing work, so just whatever, however you get it. Number 11, 3 moles undergo decomposition. How many grams of CO2? So we're going from moles to grams. So you got 3 moles of the CaCO3. And we want to know how many grams of CO2. Again, it's a 1-to-1 ratio between the two. So if we have 3 moles of CaCO3, we've actually got 3 moles of CO2 also. So we just multiply the 3 moles of CO2 by the molar mass. I got 132 grams of CO2, letter D. Number 12, 240 grams of copper 2 oxide. We want to know how many moles of H2O. So we're starting with grams and with moles. So we start with our 240 grams. The molar mass is real close to 80. So 240 divided by 80 is really around 3. So 3 moles times 1 over 1 would be also 3 moles. So the answer was B, 3 moles. Number 13, we don't know how many moles of H2O, but we got 1 mole of KMnO4. So 1 mole KMnO4. We already got moles, so we don't have to do molar mass, times 8 moles of H2O from the balanced equation, or 2 moles of KMnO4 from the balanced equation. So 1 times 8 over 2 would be 4. Answer is C. Number 14, based on the equation in question 13, that's the one we just did, how many grams of KCl? So we started with 1 mole of KMnO4. There's 2 moles of KCl for every 2 moles of KMnO4, so that's all canceling out. And the molar mass was like 74.55. I rounded it to 75 for the sake of this problem. So 1 times 2 over 2, which is also 1 times 75, should be 75, B. If 110 grams of HCl are used in the reaction, 6 HCl, how many moles of FeCl3 are produced? Well, it's 6 moles of HCl for every 2 moles of FeCl3. So we start with our 110 grams divided by 36.46, which is the molar mass, times 2 moles of FeCl3 over 6 moles of HCl. And I do the math and I get 1 mole, A. Number 16, in the reaction, how many moles of, or how many grams of H2SO4 required for 1 gram of H2? So 1 gram of H2 times 1 mole over 2 grams of H2 times 1 mole of H2SO4 per every 1 mole of H2. That's the numbers from the balanced equation. And molar mass is around 98 grams per mole for the H2SO4. So a half of 98, 49. C. Number 17, if 18 grams of carbon react with oxygen to produce carbon dioxide. So here's that equation. 18 grams carbon, 1 mole of carbon over 12 grams of carbon, that's the molar mass, times 1 mole of O2 for every 1 mole of carbon, times 6.02 times 10 to the 23rd. It's basically 18 divided by 12 is 1.5. 1.5 times 6 is 9, so it's C, 9 times 10 to the 23rd. And you can work that out on your calculator if you prefer. Given the reaction here to NO, blah, 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 if 6.5 liters of O2 react at STP, how many liters of NO2 are produced? We could multiply, or we could divide the 6.5 liters by 22.4, and then at the end multiply by 22.4, but those 22.4s are both going to cancel. So 6.5 liters times 2 moles of NO2 for every 1 mole of O2, and then so 6.5 times 2 is 13 liters, letter D. 19, given the reaction, 2 moles of zinc and 5 moles of HCl are allowed to react. All right, so I took my 2 moles divided by the coefficient. I got 2.5 moles of reaction. I took my 5 moles divided by the coefficient, which was 2. I got 2.5. 2 is, not greater than, less than 2.5, sorry. 2 is less than 2.5. So zinc is the limiting reactant, and that's letter A. Number 20, and we're going to come back to this problem. It says once the reaction is complete, and number 19, how many moles of excess reactant remain? Well, we go back here. We used 2 of the 2.5. That leaves half a mole? No, half a mole times the 2 as we go back up. So it would be 1 left over. Or you could say, since we had 2 moles of zinc, we needed 4 moles of HCl because it's a 1 to 2 relationship. So if we had 2, we used 4, we had 5, so we got 1 left over. B, 1 left over. And number 21, given the reaction, calcium carbonate makes calcium oxide plus carbon dioxide. 50 grams of calcium carbonate react to produce 20 grams of CO2 as the percent. So we got to find the actual yield, or the theoretical yield. So we'll start with our 50 grams. Molar mass is about 100, 1 over 1 because that's the balanced equation. 44 is the molar mass of CO2. I get 22 grams, theoretical. So then I take my 20 divided by the 22 times 100%, and I got 90.9%. So that's real quick through the multiple choice. If you're struggling with those, hopefully that helped. If not, we can talk about it when we get back. See you next time.